This is a video about ratios and proportions and specifically how they're involved in some forms of geometry. All right, so first let's start off by defining what a ratio is. A ratio is a comparison of two quantities by divisions. Ratios can be written as fractions or using a colon or using the word to. All right, the most common mistake that people make about ratios is they don't make sure that they're using common units. All right, and that's what we're going to be looking at here in a second. When you use common units, you got to also make sure that you simplify the fractions if necessary. Now, if you hear about something called an extended ratio, an extended ratio just simply means that you're comparing more than two things. So an extended ratio couldn't be written as a fraction, but instead they're going to say like A, B, C. And we'll see some examples of that in a minute. Okay, so let's take a look at this first example. I notice that I have a measurement of the bonsai tree at 15 inches and a Florida bald cypress tree called the Senator is 118 feet tall. They want a ratio of the height of the bonsai, I'm going to abbreviate BON, to the Senator. So I know that the bonsai tree is 15 inches, and I know that the Senator is 118 feet tall. We have a problem. Our units are not the same. Now, typically speaking, what you want to do when you have the units is convert down to the smaller unit. So inches are smaller than feet. So I'm going to say I have 15 divided by, I'm going to use my calculator here. I know that 1 foot is 12 inches. So 12 times 118 feet will give me 1416. All right. And this would be our ratio. Now, can I simplify it? I don't know. Let's see. I know, let's see, 14, 16. If I divide that by 3, that works. So I'm going to say that this simplifies to be, divide them both by 3, 5 over 472. All right. And then I would label this ratio in inches. Okay. What about this scenario? So again, they want to know about the width of the bonsai to its height. So in bonsai, they tell us here is 18 inches wide and stands 2 feet tall. All right, so if I go width to height, that's going to give me the ratio of 18 inches to 2 feet. I need to convert that to the common unit. So I'm going to go 18 over 2 times 12 will be 24. I'm going to divide both of these by 6, and that gives me 3 over 4 inches for my ratio. Okay? All right, so let's see how they can kind of take it a step further. It says members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan to buy 120 pots of flowers. The ratio, which would be tulips to daffodils, will be 2 to 3. How many pots of each type of flower do they buy? A great trick or algebraic technique to doing this problem is when they give you a ratio, we want to think of that ratio in terms of multiplying each piece by x and adding them together. So in other words, when I see 2/3, I think 2x plus 3x. I know that will tell me the ratio and the number, x is the number of flowers, okay, has to equal 120 pots of flowers. So if I solve this, I get 5x is equal to 120. If I divide, I get x is equal to 24. But now I come back and I have to recognize and understand the ratio. I know that tulips is represented by my 2x, so I'm going to take 2 times 24, which would be 48 tulips. I know that my daffodils, I'm going to abbreviate that, is represented by 3x, so I'm going to take 3 times 24, and that's going to give me 72. And just for good measure, double check by adding them, that takes me to the 120 pounds. Okay? This technique can be applied for that kind of a problem or this one, where it says the measure of two supplementary angles are in the ratio of 1 to 4. There's my ratio, so I'm going to think 1x plus 4x. Supplementary tells me that those two angles have to add up to 180. This will allow me to find x. So 5x is equal to 180. Divide by 5, x is equal to 36. They want to know what are the measures of the angles. So they want to know both angles. So one angle is equal to 1 times 36, or 36. And the second angle would be 4 times 36, which would be 144. And again, just for good measure, double check that they add up to be 180, which is what I assumed. All right. How about the lengths of the sides in an extended ratio? So now I look at this ratio 3, 5, 6. All right. I know that if I take that ratio and write it as 3x plus 5x plus 6x, that will, because we're dealing with sides, that will give me the perimeter. And that's what they give me next. The perimeter is 98. This will allow me to find x. So if I combine my like terms here, I have 14x is equal to 98. Divide to solve, I get x is equal to 7. The question, however, says, what is the length of the longest side? The longest side is represented by this 6x, so the longest can be found by taking 6 times 7, or 42, and they do give me a unit of measure, so it'd be 42 inches. All right, what if the lengths of the sides, again, a similar type of problem, except this time they're using 60 centimeters. So I would say 4x plus 7x plus 9x equals 60. If I solve this, I get 20x equals 60, or x is equal to 3. Now I look at the question. It says, what are the lengths of the sides? They want to know all three sides. So I'm going to call one side, I'm going to call it 4x. And I know 4x is really saying 4 times 3, where its measurement is 12 centimeters. Another side is 7x. So I know that tells me take 7 times 3, which would be 21 centimeters. And the third side would be 9x, which I know is telling me take 9 times 3, which would be 27 centimeters. So you guys can see there's a lot of variations for how they can give you these ratios and apply them to problem situations. The last thing we want to talk about today is this idea of what is called a proportion. A proportion, by definition, simply says an equation with two fractions. Now, because it's an equation, that means it has an equal sign. So really what a proportion is two equal fractions. All right? Many of you guys learned in the past this cross product property, but you learned it as cross multiplication. You probably didn't learn it as the product of the extremes equals the product of the means. All right, that's okay. That's another way to look at it. But ultimately, if you have a proportion, we know that we can cross multiply to solve. And that's what this is saying. Okay, it's an example over on the right just to help you. Now, for these two examples, they want us to solve it. So there's A. We need to find A in this first problem. I'm going to cross multiply, so 2A equals 9 times 14. Or 2A equals, why am I blanking on this? 9 times 14 will be 126. Divide to solve, I get A is equal to 63. If they made the proportion a little bit different, notice I have an M there and an M there. Well, when one part of the extreme or the mean is now an expression, make sure you put it in parentheses. To solve this, I'm going to cross multiply. It doesn't matter which order. I'm going to go 15 times m equals 3 times m plus 1. So we're still cross multiplying. It just doesn't matter which one we do first and which one we do second, all right, to get the product. If I clean this up, I get 15m is equal to 3m plus 3. Subtract 3m from both sides, so that would give me 12m is equal to 3. Divide to solve, m is 3 over 12, but I would never leave a fraction unsimplified. So I'd reduce this down to 1/4. All right? What these properties of proportions are, guys, is just different ways that they can write the exact same proportion. Okay? So you can kind of take a look at that, study that, kind of see how it's being applied. But let's do it for a couple of problems here just to make sure you see it. Notice they give us this proportion. What they want us to do is to figure out x over y based off the proportion they gave us must equal what? Well, I know x matches with 6, so I'm going to put 6. Y matches with 7, so there's literally my answer. That's all you have to do. All right? So take a look at these next two. I've got x over 6 equals y over 7. So if I look at this one, 6 over x has to equal, let's see, 6 over x. I just took that first fraction and flip it. So take the second fraction and flip it. All right? And there's the answer. Now this last one, a little bit different. Okay? I'm going to rewrite it as y plus 7 over 7. If I look at the y and the 7, I notice what they really did was they added the bottom to the top and rewrote the bottom. So I'm going to add the 6 to the x plus 6 over this x. And that is the equivalent proportion. This whole thing together is the equivalent proportion. All right, hope this helps. Let me know if you have any questions.